Well, hello GeoData people. Today we're continuing Investigation 3 in Unit 4. We're going to be doing Lessons 3 and 4 today. We've already done Lessons 1 and 2 in previous lessons. So we're starting Lesson 3 today on page 155 in the workbook. And we're going to be using those trigonometric functions, those trig functions, sine, cosine, and maybe tangent, to solve some problems where we don't know what the side measurements of a triangle are, but we know the angles. So we're going to start with this triangle here. We know it's a right triangle. Trig functions work with right triangles. And we know the two angles are 40 and 50. We know the hypotenuse has a measurement of 26. We do not know the measures of sides A or B. So we're going to use the sine of 40. We're going to use our 40-degree angle to be our angle that we're interested in. And we're going to use the sine of 40 in order to figure out how long side A is. Well, side A is the side opposite, on the opposite side of the triangle from that 40-degree angle. So if you remember, the sine of an angle is the measurement of the opposite side divided by the measurement of the hypotenuse. So in this triangle, the sine of that 40-degree angle is going to be the opposite side A divided by the hypotenuse, which is 26. All right, so that is the definition of sine. So, in order to calculate the length of A, we need to know how much is sine of 40 degrees. So there are two ways we can do that. One way is to look at the table that we completed in the warm-up. And that table said for each of these degree measurements, we had calculated the sine values and the cosine values. So here's our 40-degree angle. And the sine of 40 degrees is 0.643. So we're going to use that. The sine of 40 degrees is 0.643. If we did not have that handy table, we could use a calculator. And this is all you have to do on a calculator. There are keys on the calculator for the sine and the cosine and the tangent. So on the calculator, you would just hit the button that says sine, S-I-N is the abbreviation, and you would say 40 degrees. The calculator is set to be reading degrees, so I just say 40, and it knows degrees. And you hit enter, and it rounds to 0.643. Okay, so we know the sine of 40 is 0.643. We also know that the sine of 40 is A divided by 26, A over 26. So there's our equation, and all we need to do is solve it. So if we multiply both sides times 26, we get that A equals, that cancels, A equals 26 times 0.643. And 26 times 0.643 is 16.7. So that is our answer, 16.7. Now, what if instead of using the sine of 40, what if we had used our 50-degree angle instead? Well, then A is not the opposite side to the 50-degree angle, it's the adjacent side. So we could have said cosine of 50. And if you remember, cosine is adjacent over hypotenuse. So the adjacent over hypotenuse would be A over 26, because now A is the adjacent side. Well, if we look up the cosine of 50 degrees, now we're not looking at sine, we're looking at cosine. Oh, look, it's 0.643. And it's the same calculation. A is 26 times 643, which is 16.7. Okay, now what if we wanted to calculate how long the other side of the triangle was? Now that we know A is 16.7, what if we want to know B? Well, now we know we can use either the 40 or the 50-degree angle, depending on whether we want to use the sine or the cosine. Let's use the 50-degree angle. So let's use the sine of 50 would be opposite over hypotenuse. The opposite side to the 50-degree angle is B. The hypotenuse is 26. And the sine of 50, sine of 50 is 0.766. So that is 0.766, which means B is 26 times 0.766, which is 20. And if we did the cosine of 40 degrees, it would turn out exactly the same way. All right, so let's use this to solve a problem. So let's go on to the next page, 156, and let's do this problem. So there's a ship, and it started at the dock right here. And they set sail to go exactly 27 degrees northeast, which faces that way. That's our 27-degree angle from straight ahead. And then after they had gone 120 miles and they stopped there, the captain said, "Oh, no, I was supposed to go directly east. I was not supposed to go that 27-degree angle up. I have to go south now and get back on course." And then when he gets here, he'll continue on, right? So what that has done is that has made a right triangle. And here is the 90-degree angle. And that 120 miles that he sailed is, of course, the hypotenuse. Now, what they're asking us is how far does he have to travel south to get back on track? So that's the question that we're answering there. So which function would we want? If this is our angle, we know we're going to use the hypotenuse, and we need this side. Well, that is the opposite side from the 27-degree angle. So we need the relationship that's opposite over hypotenuse, and that's sine. So we need our sine of 27 degrees. And in the problem, that's x divided by 120, opposite over hypotenuse. And what we need to do is use our calculator to find out what is the sine of 27 degrees. And the sine of 27 degrees is 0.454. So if we want to solve x divided by 120 equals 0.454 times 120 on both sides, then x is 54.5 miles. So that is how far he has to travel south to get back on track. All right. So we can use our sine and our cosine and our tangent functions if we know the angles and we know one of the side measurements. We can find the other side measurements. Well, you know functions work in reverse. So what if we know the side measurements but we don't know the angles? Well, then we're going to use what's called inverse trig functions. And it just means we're going to go in reverse. We're going to go backwards. Okay, we're going to do the inverse, the opposite function. So this is what that's going to look like. We're going to go on to page 159 now. And here's an example of using the inverse function. What if, and I'll draw a picture for this first one here. What if we have a triangle, and it's a right triangle, and we know the hypotenuse is 20, and we know that this side is 13. We don't know that angle measurement. That's all we know, is that it's a right triangle with a 13 measure leg and a 20 measure hypotenuse. Well, the sine of angle B would be opposite over hypotenuse, which would be 13 over 20. And if you do 13 over 20 on your calculator, 13 divided by 20 is 0.65. And then what we're going to do is this inverse function. So on your calculator, there's a second key, and if you hit the second key, your sine and cosine and tangent become sine -1. That's inverse sine when it has a little -1 up in the air. So we're going to do the inverse sine of that 0.65 because we want to go backwards. And that says the angle was 40.5 degrees. Okay? So if you know the angle, the sign will tell you, if you know the angle, this is the side. The inverse sign says, well, if you know the side, I can tell you the angle. Okay, it goes backwards. So look at this one. If we know the cosine of an angle is 1/2, then all we have to do on our calculator is say, then what is the inverse cosine of 0.5, which is 1/2? And it's 60 degrees. Okay. What about the tangent? If we know the tangent is 45/31, so we do 45 divided by 31 is 1.45 rounded. So if I do the inverse tangent of 1.45, I get 55.4 degrees. Okay, and the last one. If I know the sine is 3/4, 0.75, then if I want to know the angle, I just say the inverse sine, so there's my sine to the -1 power, of 0.75 equals 48.6 degrees. All right, so as long as I know the measurements, I can find the angles. So let's do that in a problem. Here's a triangle. And we know this is a 90 degree, so we can use our trig functions. This side is a measure of 5. This side is a measure of 12. What if I want to know what is the measure of angle A? Well, for angle A, this is the opposite side, and this is the adjacent side. And the third trig function, tangent, is opposite divided by adjacent, which in this case would be 12 divided by 5. So 12 divided by 5. So if I want to know what the angle is, I would say, what is the inverse tangent, tan to the -1, of 12/5? And that will tell me the angle. 12/5 is 2.4. So 12 divided by 5 is 2.4, and I would do the inverse tangent of 2.4, 67.4 if you round. Okay? And then, of course, once you know A, you can calculate B because you know they have to add up to 180, so you don't even need to do the trig functions to find that one. Okay. So I want to show you an example where people would use this in real life. So the Americans with Disability Act says that there's a rule for how steep a handicap ramp has to be, right? If it can't be too steep or people would get hurt trying to use it, it has to be gradual. It has to have an angle measure that's 4.75 degrees or less. If it's any more than 4.75 degrees, it's too steep and it's out of code. It's illegal. So what if there was a handicap ramp? Okay. And the rise, which is how far the top of the ramp is from the ground, the rise is 4.5 feet. And the run from the beginning of the ramp along the ground to where the ramp ends is 38 feet. And they're saying, is this legal? Does this meet the Americans with Disability Act specifications? So this is our angle. That's our theta angle. What function would use opposite and adjacent? That would be tangent. So we know that the tangent of theta is 4.5 divided by 38, which is 0.118. I used my calculator. So what we need to do is the tangent negative to the -1, or the inverse tangent of 0.118. Because we're saying we know the tangent is 0.118. What is the angle that would give us that tangent? And the angle is 6.7 degrees. So is that legal? Is it legal? Does it meet specifications? No. It's too steep. It can only be 4.75 degrees, and this one is 6.7. It's much too steep. Okay, so I want to show you one more thing that's in lesson 4, and that's on page 167. So on page 167, we're going to talk quickly about complementary angles. Okay, so if you remember complementary angles, they add up to 90. So if we have an angle that's 10 degrees, its complementary angle would be 80 degrees. If we have an angle that's 30 degrees, its complementary angle would be 60 degrees. If we have a 50-degree angle, its complementary angle would be 40 degrees. Okay, as long as they add up to 90. So look at this triangle here. Here's angle A. The sine of angle A is going to be, remember, sine opposite over hypotenuse, so A over C. The sine of angle B is going to be the opposite of B, which is side B, divided by the hypotenuse. Well, what's the cosine of B? The cosine of B is going to be the adjacent side. So side A is the adjacent side to that angle, divided by the hypotenuse. And the cosine of angle A is going to be this side A, cosine is going to be this side B, the adjacent side, divided by the hypotenuse. Well, look at the sine of A is the same as the cosine of B. The sine of B is the same as the cosine of A. You might have noticed that back in the warm-up when we did this. Look at, did you notice how the numbers form a pattern, right? The 40 and 50 numbers are just opposite. The 30 and 60 numbers are opposite, right? The 20 and the 70. The sine of one is the cosine of the other, right? And the same thing with 10 and 80, and actually the same with 0 and 90. So those complementary pairs, there is a pattern. If you have two angles that add up to 90 degrees, so that the measure of one is 90 minus the measure of the other, those are called complementary angles. And the sine of theta would be the cosine of 90 minus theta. The cosine of theta would be the sine of 90 minus theta. Okay? That is sometimes a useful thing to know. So that's all for these lessons, you guys. Now you can go back to the whiteboard chat and finish up the lesson. Bye.